Hello and welcome to section 4.4, the fundamental theorem of calculus. And in this section we are going to basically learn the quicker way of solving these integrals without having to go through the limit definition and summation. And so what the fundamental theorem of calculus says is that if we have an integral of, say, f of x from a to b, we can take the antiderivative of this, and I'm going to put a prime here so that we get f of b minus f of a. And this is basically backing up, we take the antiderivative, get our new function, plug in b, and then plug in a and subtract them. So that's what we're going to be doing for these problems. And so I'm going to take the integral of this and end up with x cubed over 3 minus 3x. And this function then, I will use the 1 and the 2, and since it is b minus a, I'll put 2 in, so it'll be 2 cubed over 3 minus 3 times 2. That's my first thing. And then I subtract away, putting in 1. Let me move this out of the way here. Well, I'll move all of it. There we go. Move all of it out of the way. And then putting in 1. I end up with 1 cubed over 3 minus 3 times 1. And so now it's just a number crunch to get this. We have 8/3 minus 6. And we're subtracting away 1/3, and we're adding on 3. So if I was doing this, I'd try not to combine the things inside the parentheses. Just make sure I distribute my negative sign to both terms, because -6 and -3 will give me a nice little -3 number. And then minus 1/3 from 8/3 will turn that into 7/3. So I'm adding on 7/3. Now I have to combine them, and so I have a -9/3 plus 7/3, which means this is -2/3 is the answer to this integration. Well, it works the same for square roots, and in this problem we're going from 1 to 4, and so I could pull out my constant multiple and go from 1 to 4 of x to the 1/2 dx, and when I do my integration it's going to be 3 times, well, raising it by a power would change it to 3, so it would be x to the 3/2 divided by 3/2. And then I'm going from 1 to 4, and I've simplified this a little bit, so then I have 3 times 2/3 of x to the 3/2, which will cancel out the 3's, and so all of this simplification gets me 2 times x to the 3/2 from 1 to 4. And so now I plug in 4, and so this will turn into 2 times 4 to the 3/2 power minus 2 times 1 to the 3/2 power. Well, 3/2 power, remember you can do this in any order that you want. I'm going to take the square root of 4, which is the bottom of the fraction, get an answer, and then cube it. So I have 2 times 8 for that one, minus, and then square root of 1 is 1, and then cubing is 1, so it's just minus 2. So this ends up being 16 take away 2, which gives me an area of 14. And then finally, for secant squared x, with this integral, I need to remember what did I differentiate to get secant squared, and I believe that was tangent. And so when we do the integration of this, this turns into tangent of x from 0 to pi over 4. And so then it's really, this will turn into tangent of pi over 4 minus tangent of 0. And tangent of pi over 4, I believe, is 1, and tangent of 0 is just 0. So my final answer for that is an area of 1. And so this is really what we're doing for these guys. This doesn't work for everything, but this is a start, and we'll talk more about it in class. I have one more example that pops up. We want to find the area of the region bounded by this curve and between 0 and 2. So first thing you have to do is set up the integral, which would be from 0 to 2 of this function. And so there's my integral, and now I can go ahead and integrate this, which gives me 2x cubed over 3 minus 3x squared over 2 plus 2x. And I'm supposed to get a plus c on here, but I'm adding a constant, and that constant gets added and subtracted. So I'm going to add it on just because we hadn't really talked about it. I'm going to add that constant on, but watch what happens when I do this. When I plug in 2, I get 2 times 2 cubed over 3 minus 3 times 2 squared over 2 plus 2 times 2 plus c. And then all of that I need to subtract away, plugging in 0 for each one of these. So I get basically 0 minus 0 plus 0 plus c. But look what happens. This negative sign will go to that c, and the c values will cancel out. And so maybe after that last example, you guys were asking what happened to that. And so this is all I really needed. 0 is always our magic number for these. It makes life a little bit easier. Not always, but it's a pretty good indicator. So I end up with, this is, let's see, 16 over 3 minus, let's see, 6, and then plus 4. So I'm going to combine my whole numbers, which is 16 thirds minus 2. And so then if I get a common denominator, 16 thirds minus 6 thirds will give me a final answer of 10 thirds for the area under that curve. And that's really all we're trying to do with these guys. So if you have any questions, please come to class prepared to ask them, and we'll talk more about this in class. Thank you.